a rational equation is f of x equals 1 over x, you have to have a variable in the denominator for these. So this graph is going to have a domain of negative infinity to 0 and 0 to infinity. Basically, that's all numbers except what? 0. It does not include 0. The reason it cannot include 0 is because if we plug 0 in here, we get 1 divided by 0. And 1 divided by 0 is, starts with a U, undefined. It's undefined, so it's not going to be an actual number that you can graph. So you're going to have a vertical asymptote at x equals 0, which is your y-axis, and a horizontal asymptote at y equals 0, which is your x-axis there. So these are just general characteristics of a rational function, right? The big thing we're going to be looking at is if we move this up, it's going to move that horizontal asymptote up. If we move it left, it's going to move that horizontal asymptote to the left. So, let's all go to the next slide. Choose an answer there. Let's see how many I got. I got a couple more that need to choose an answer. So go ahead and pick something there. All right, let's look at our results. All right, so most of us picked this graph. I want to show it bigger, but it won't. In which the graph has basically just been slid left 2. Right? So for this, at x plus 2, remember a rational has some imaginary parentheses in that denominator. If we put a plus 2 in that denominator, it is going to move it to the left or right, and it goes the opposite direction. So since we put a positive number, it actually moves it in the negative direction. It moves it left 2. So looks like everybody's switched theirs to the right answer there now. Okay? All right, go to the next one. And I want you to tell me the horizontal asymptote of this one. All right, go ahead and pick one there. A little more. We got two that are pretty close on this one. So let's see what we think. Here are our results. Most people said y equals 7. But we had a pretty significant number say x equals 3. Okay? So, first of all, this is something that should be so easy, but even sometimes I myself get it mixed up. Okay? We have a vertical and a horizontal line. Vertical lines, what do their equations look like? X equals some number, right? And horizontal lines are going to be y equals some number. So, x equals 3 and x equals 7 can be thrown out. They are vertical lines, so they can't be your horizontal asymptote. So based on that information, that kind of changes probably what we think our answer is there. So if you want to change it to y equals 7. So think about what's happening. You've got a graph that looks like this. No, you don't. Your graph looks like this. The rational graph looks like this. So that horizontal asymptote is right there in the middle on the x-axis. What's the only way we can move that? We can only move it by moving it up or down, right? So, correct, I shouldn't say right when we're talking about shifting things up and down. So, we can only move this by moving it up or down. So, this has been moved up 7. So, it takes that line that was y equals 0 and it moves it up 7. So, that will be our answer for this one. Okay? All right, let's see. Let's go back over here. All right, go to the next one. Pick one there. All right, go ahead and make a decision on that one. All right, let's see what we got. Okay, we're pretty good on this. Most everybody chose this one. It shows the graph so tiny. Wait, can I do that? There we go. And this is the one that's been shifted down 1, and it should have went to the right 3 on that. So down 1, right 3. We also had a few students choose this one. So this one, they still went to the right, but it went up for that one. So remember that number on the end, you do actually go that direction. So it'll be down 1 for that. So we should have this one chosen. Okay. Any questions so far? All right. So the fun stuff here. Let me go back to the student. All right. I think these are cool. All right. So this is just an example page right here. This activity, I added in like some note questions like the ones that we just did, but it's called a marble slide. Desmos puts these out, and I've just adjusted it a little bit. So the point of these is for you to create some sort of graph that whenever you click the launch button over here, all your little purple balls are going to hit those stars and make them go away. So, so that's just an example right there. Go on to the next slide. So if I look at what I've got here, this is called Fix-It number 1. If I click the launch right now, this gets most of the stars, but it does not get all of the stars. So that is unsuccessful. We want to get all of the stars. So it asks us over here to change one number in the row below to fix the marble slide. So if I'm thinking about this blue graph, what do I want to do to it so that I would hit all of those right there? What could fix this? Okay, if I switch it, if I slide it over to the right side here, if I kind of get that blue line lined up right here, then it would help, right? So right now, I've got a +1, which moves it to the left 1. So Troy is telling me to make this a -1. Does that look better? Let's see if it works. It does not work. But I think his idea,
it worked on mine.
Sometimes it will work once and then not work a second time. So it's not working on mine. But how could I fix mine so that it would work? Well, it only wanted me to change one number. Let's try like 1.5. Okay? So mine was not quite far enough over. And it is kind of weird on these. Like sometimes two kids can have the same equations, and I guess it's where you're like so close to the barrier there, like it's got some sort of variability. I'm not sure exactly why it works like this, but if I change mine to 1.5, it worked because mine needed to go just a little bit further to hit that graph right there. So that one worked. Some of you were getting it to work with -1, so as long as everybody make sure you have hit launch, and because once you have gotten rid of all your stars, it gives me a check mark here showing that you've done it correctly. So let's go over to the next one. Okay, so this is sort of your note part of it. We're not going to write it all down, but the purple graph here, this purple dotted line, that's our basic parent function. So the red graph shows us what happens if we flip that graph upside down. Now, for this graph, this is a little bit like your x squared graph. Well, not exactly on this. So if we reflect this over the x-axis, that would mean this purple part right here flips and becomes this red part right here. And this purple part down here flips up here and becomes the red part. But if I put the negative down here in the denominator, inside of the parentheses, it would flip it over the y-axis. But that means this purple part right here flips over here and becomes this red part. And this purple part flips over here and becomes this red part. So does it make a difference whether or not you flip it over the x or the y-axis for this graph? It does not. For this particular graph. Now, it would make a difference on a cubic function or a square root function. But for a rational function, this negative right here that flips the graph, it doesn't matter whether you put it in the top, you can put it in the bottom, or you can put it out front. All of those are going to produce this red graph right here. Right? So it doesn't matter where you put it. It's more typical to see it written out here out front. That's what you're going to see answer choices look like more often than not. So if I go to this next one right here, we are supposed to change just the sign of one number in order to make this hit the... Okay, so we put a negative right here, and then I click my launch button. There we go. That's all we had to do is flip it, and it gave us the right shape that we were looking for there. All right, so I could put that negative right there out front. Watch this. I could put the negative in front of that 4. It looks just the same, right? I could. Now, I don't know why you would want to do this. You can put the negative in the bottom. But if you put the negative in the bottom, now that doesn't look the same, right? You would have to put parentheses around that x minus 1. But in general, I would just not worry about messing with what I would probably do here, oops, I would not do that because that changes the whole problem, as I would just put that negative out front. We'll flip it for us. Okay? All right, let's go to the next one. Okay? Now, something else that we can do to this graph that will make it look a lot different is we can square our x. So this is not a specific transformation that we looked at in particular, right? So this does not necessarily do the same thing for every graph. So that's why it was not in those list of things that we looked at yesterday. But for rationals, if I square the x, notice how it makes this red graph a little bit steeper right here. And it also takes this negative part of this graph and it flips it upward, right? So if we are wanting like the one they had here where we kind of got like a funnel, one thing that you can do for this graph is you can, oh wait, where'd I go? You can make that x squared instead of just a regular x, and then it'll have them both going in the same direction. There. So, another skill that you're going to have, because in a moment you're going to have a bunch of marble slides and you got to come up with the equations on your own, is we can restrict domain. So if we want to restrict the domain of a function, we'll just type in our function, and then out next to the end we'll use our squiggly brackets, and we will tell it something like x is less than 5. And so notice that it graphs the whole function except for right here at 5, where x equals 5, it stops the graph. That might be helpful because we might need to cut the graph off, because we might need to make like a hole where all the little balls can fall through, right? If I want to change this, like if I make it 7, notice now the graph goes all the way out to 7. I could even do something like this. Sometimes you just want it like between 2 points. So let's say I only wanted this graph from like -2 up to 7 for some reason. I could do -2 less than x less than 7, and it would only give me that part right there between those two values. So the domain can sometimes be restricted. So if we go to the next fix-it problem, right now, if I click launch, all of the balls just fall down to the ground. So I want you to change one number over here that is going to fix that. And when you get it to work, it'll put you a check mark over here. And so why is that not doing this? This used to just show the screen. Why is it doing that? I don't want that. Well, let's see what it looks like. Okay, never mind. If I just click on teacher, it gives me what I want. Okay. So like several of you, let's look at some that look different. So Madhava here changed it to 11, and it's a little slow going, but I'm pretty sure it's going to work just fine. Look, that one got stuck, but it still got all of the stars there. Let's see if there's one that looks different. This one might be Charles Lewis. Used 12. Really, as long as the number is bigger than 10, right? 10 might work. Did anybody do 10? Did I do 10? Let's see if I got it. I'm just going to change somebody's to 10 to see if it works. They might, some of them go the wrong way, but some of them still go the right way, so it still gets those. But as long as you're 10 or more, it should work for that. So that's how we restrict our domain. Vertical expansions and compressions. So sometimes we might need to like stretch this out or shrink it down. So what I've put on this slide is I just put in f of x equals a over x. So that number that you put in the top of that function, so like if I want the parent function, it would just, in fact, let me graph f or g of x equals 1 over x. I'm going to put that in, and I'm going to change its color to blue so you can see. That's the parent function there. And so if I take this, if I make that top number bigger, see how I've got like 5.7 over x, that's stretching it out on the y-axis. And it's making it look less steep. If I make that number smaller, like if I do 0.3, you can see that my red graph, now it's squishing it down. It makes it more steep. What happens when this flips over here to a negative number? The whole graph flips. So if you go to a negative there, it's going to flip the whole graph. The negative flips there. So, everybody choose an answer for this one. Go ahead and pick one for that. And let's look at our results. Okay, so we did have one person pick this one down here. What's a plus 20 on the end of the graph going to do? It moves the whole graph up. So what we would see is like the horizontal asymptote right here would be moved all the way up to 20. So the graph itself would not be steeper or less steep. It would move the whole thing up. So it would not be that one. And then we have more students picking this one than the other. I do think these are a little bit hard to tell. What we're doing here is if we put the 20 in the top, we're taking this and stretching it this way, which is going to make it look less steep. So that is the correct answer. If we put the 20 in the bottom, that's horizontal, and it's going to be, we're putting a big number, which compresses it, so it's going to squeeze it in even closer to that x-axis, so it would make this graph like even steeper there. I think these are a little difficult to tell for sure. So let me give you, this is important because there will be a quiz question that will look a lot like this. And it'll ask you to give me the equation of that red graph. And it's a little hard to think about just picturing it to me. But here is something you can always do. Okay, you can always do this. All right. So when I look at that red graph, I'm going to find me some points that are actually on the red graph. Right? So this is the point 5, 4. So, and this is the point 4, 5. So if I plug 5 into this equation, f of 5, I would do 20 over 5, and 20 divided by 5 is 4. So that tells me the point 5, 4 is on that graph. If I try that down here, f of 5 would equal 1 over 20 times 5, which would give me 1 over 100. So 5, 4 is on this graph. This would tell me that the point 5, 1 over 100 is on the graph. That is not on that red graph right there. So when you're unsure, a lot of times there'll be like a couple that you're unsure, like you might be able to rule out a couple others, but there's some that you're unsure about. Try just picking a point and plugging it in. If I had picked 4 right here, if I do f of 4, that would be 20 over 4, which would give me 5. So that would mean I'd have the point, the x I plugged in was 4, the y I got out was 5, so 4, 5. Also a point on the graph right there. So if you can find points on the graph and plug those in, that can guarantee that you've got a point. That's one of the more missed questions I usually see when we get to the quiz for this part, because students have 2 that they've narrowed it down between and they can't tell which one's been stretched out or not. So if you plug in points, it'll help you for that. All right, so let's go to our next one. All right, so I want you guys to fix this by changing only one number here so that you can get your stars to go away. And when you do, it'll give me a check mark here. So Mariel Vasquez has already got it. All right, it looks like most of you have that one. What did you guys change your top number to? 15? Okay. 15 worked for me. Some of you used a little bit higher number, but something around 15 or so seems to work for that. So you'll see it doesn't have, like, whenever we're doing these problems, like, you may not have exactly the same thing. It's more in the understanding of, like, what is this going to do to this graph that we're really searching for. All right, so in this equation right here, you are going to type in what you think. If we changed the 5 to a 10 in this equation that you see here, what would happen to the graph? Okay. All right, let's look at some of the answers we've got here. These are looking good. The line would cut off at 10 instead of 5. The graph would end at 10 instead of 5. The graph would end at x equals 10. We're seeing a lot of the same things. I like Charles Lewis' reason down here. He's using some fancy math words. The domain would be extended by 5 to the right, making the x value reach 10. So you didn't necessarily have to use the word domain, but that's what you're doing. You're extending that domain for the graph. So it looks like everybody's pretty much on the same page there. We said it a lot of different ways, but we're on the same page. All right, so it asks us on the next slide just to verify that that does in fact happen. So if you change it to 10, zoom out, you can see, yes, it does extend over there to 10. So that's all they want you to do on that one. Okay, this is a little bit hard to see. This says y equals 1 over x minus 3 plus 4, and then x is less than 8. So this time you're going to tell what's going to happen if you change that 4 to a 1. Okay, I was particularly interested in what I'd see for this one because there is a question like this on the quiz also. And so you guys have said this in lots of different ways. Let's talk about which ones are correct and which ones maybe aren't correct, and possibly some that are just not specific enough. So I'm going to go through all of these here. So Gloria says the graph would shift down. Do you guys agree? So where it's at right now, if we change that 4 to a 1, the graph goes down, right? Gloria is not being very specific here, and don't change your answers right now, because I want to talk about all of them, because sometimes the wrong answers help us learn more than the right answers, if there is a wrong answer. So Gloria is not being very specific, but what she has said is true. right? Now, if this was a multiple choice question, it would probably be more specific to that than that. All right, Mary said the entire graph would shift down to have a horizontal asymptote at y equals 1 instead of y equals 4. You guys agree with that? Okay, the horizontal asymptote was at 4. Now it's at y equals 1. I think that that is correct. The way that Mary has said this is beautiful, and it's more specific than Gloria, right? Not that Gloria was incorrect, she just wasn't as specific. But, you know, this was a free response question there. All right. Graph would be moved up 1 instead of 4. Is this correct? Kind of. The question for the way this has been worded is, what is the graph that they're talking about? What graph do they mean whenever they're talking about the graph being moved up 1 instead of 4? They're talking about like that parent function, right? That rational parent, the 1 over x. Because if we put the plus 4 here, it moves the parent function up 4 versus moving the parent function only up 1. So for that one to be better, it should say it moves the parent function 1 over x up 1 instead of moving it up 4. Because in actuality, when we change that 4 to 1, if you say the graph, and I think you were talking about the original graph, does the original graph move up or down? If our original graph is 1 over x minus 3 plus 4. It moves down, right, from our original graph, from our y equals that we have right here. So you want to be careful with that because it depends on how the question is asked, whether or not that would be accurate, whether you're talking about parent function or the original function. I would argue that someone who says the graph should be talking about the 1 over x minus 3 plus 4. So I would say that Fan Chung here should probably refine his or her language there. This one talks about the horizontal asymptote. This is true. It's perfectly fine. Madhava doesn't talk about whether or not a graph has been moved up or down any, right? So it is still correct, but it doesn't talk about direction any at all. Mariel says the graph would move lower on the graph. The plus 4 makes it raise 4 units. So if it were a 1, it would move down 3 units. I get the idea. This person has a correct understanding of what's happening here, I think. But whenever Mariel says the graph would move lower, which graph are they talking about? Original or parent function? Original. Then they say the plus 4 makes it raise 4 units. What are they talking about here when they say it? Parent function. So that were to be a 1, it would move down 3 units. What's it talking about when it says, what's Mariel talking about whenever he or she says it right here? The original. So you can see the confusion about the meaning of those. So I tell my calculus students that we do not say the word it when we are explaining something. Because if you say it, I'm going to ask what it is. I tell them that it is like a calculus cuss word. Because we have to do a lot of like writing to explain, and they'll say it is positive on this interval, so the graph is increasing. Like, you have to say f of x, or the original function, or the parent function. You have to be specific. So although I think this person totally understands the idea of what's happening here, they have not communicated it very precisely. Okay, the graph would shift down 3 points. I would probably say units instead of points, but I would assume the way this question has been asked, if you talk about the graph, you're talking about what's graphed right here. So I would say that that is good, right? Because we went from having a horizontal asymptote at 4 down to horizontal asymptote at 1. That moved the original graph down 4 units. Very similar for this one. So the graph would move down to 1. They talked about the original graph moving down, but it would be better if we talked about what exactly is at 1. right? So the horizontal asymptote of the graph would be moved down to 1 would be a better way to say that. The graph will be at the 1 on the y-axis instead of up 4. I would talk about asymptote here to be more specific on that. Again, here, the graph would move up 1 instead of 4. The person's getting the idea, but they mean parent function here instead of the graph that is original. Let's see. Graph would go up 1. That just changed to a y-axis. So good. It would go down 3 from its current position. So, again, idea's correct. Be careful with the language because of what you would have there. Horizontal asymptote there. So, talking about the horizontal asymptote is good because that's very specific language. And if you're referring to the graph, I would say the way this is presented, because that graph that you're looking at is 1 over x minus 3 plus 4, you should say that the graph moves down 3 for that. So most of the time, you're going to see this as multiple choice. You're not going to be typing in answers a lot, mostly for the ease of my grading, because I cannot keep up with grading if I have to grade everything by hand. And it's not helpful for you to get your grades back 2 weeks after you take a test. So I don't grade a ton of stuff by hand for that reason. So you're probably going to see this multiple choice, which means what I am probably going to say is that the graph's been moved down 3 units. So be careful with that. You can get distracted by some other answer choices if you're thinking about the 1 and the 4. Think about where you started, how much it changed whenever you changed that. All right, so the end of this is going to be final challenges. We're going to do the first one together, so you should get it right. Okay? All right, so we're going to have, all of these are challenge slides. Some of these become difficult. Very difficult, actually. All right, so you are only allowed to use rational functions. A rational function has an x in the bottom of the equation. So let me go ahead and say this right here. F of x, if I type in an equation, f of x equals x over 2, is that rational? It is not. What is it? It's linear. The x has to be in the bottom. So if I start off with, I'm going to start off on this one with 1 over x right here. And what does it look like? I probably need to do this graph. Probably need to slide it up some there. Maybe like a horizontal asymptote at 5 might be good. So I'm going to put a plus 5 right there. You can test it, see if it's working. It's almost got it, but I'm missing this star right here. So what do you guys think I might could do to get that star? Put a 2 right there. That makes it a little less steep. That'll get it. And it might not be the only thing that would have worked. Like, maybe, let's see if it would work if I did like a 0.5 right there. This might get it. It did. Like, so if I just moved it up a little bit more, that also worked. So what you do might not be the same as what your neighbor did, but they both could work right there. So I think it's prettiest with that 2 over x plus 5, but it doesn't have to be 2 over x plus 5. Okay? This is by far the easiest one that you're going to do. They get much more difficult. So I'm not going to do number 24, but I'm going to skip down to number 24. All right, so for this right here, those are in a perfect line. It would be great if I did like y equals negative 1/2 x. Maybe like negative 1/3. Okay. Actually, oh no, this is an issue though. All right, first of all, can I even do this? Is that rational? It is not. So I can't do that. Also, even if I did do this, it's not going to get all of the stars because they won't roll back up the line. The gravity is taken over. So I have got to do something. I need to get my little balls to go over here first, so then they can go down here, right? So I might want to, like, I'm going to do what I would probably do. So if I do y equals 1 over x, I'm going to put a negative out front, which is going to flip that over. I'm going to move it up 10. Okay? So that gets, actually I might even move it to the right, or to the left 4. Now let's go 6. Okay? So this makes this nice little piece right here that'll move they'll get the balls to go over this way, right? But I don't want that whole graph, right? So I could restrict it from like, I really want it to stop maybe at like negative 18 is less than x less than, the asymptote is at 6, so less than negative 6. I really only want like this part of the graph, right? So now this would get all of the balls to go in this direction like I want it to go, but right now they're just going to fall off into the abyss. So if I could get a line that would come along here, then I could get the balls to go down and get those stars, right? So what I would need to do is do like a second one, y equals 1 over x, right? And so this is not going to work as it is, but it would at least be in the right direction because all of the balls would go this way. Yeah, I need something that's slanted this way, but it's at least getting it down to stopping it there so they don't go away. So you would have to work on a second rational equation. So you can use as many as you want. They just all need to be rational. Okay, they can't be lines. Now it would be great, like if I did negative 1/3 x minus 0.5, like this would work beautifully right here. I think. Unless it gets too much momentum going that way. Oh, look at that. That is lovely. But I'm not going to give you credit for it because that second line that you put in there is not a rational function. And I want us practicing with rationals. So, like, obviously it would work, but it's not what I want you to do for that one. We did the first one together, so that one doesn't count for anything. So your homework tonight is to try something on a few of these. So I need to see that you have tried something on, let's say, at least 3 of them, besides the first one, because we did the first one all together. Okay? I will be offering you, for each one that you get to work, I will offer you 1 extra credit point on the quiz that we're going to take on Thursday. Okay? So we did the first one together, so it does not count. But then you've got 2, 3, 4, 5, 6. How far does it go? 7, 8. Yeah, there's 9. 9, you like put the stars where you want. I think. How do I do that? No. How do I put the stars on? I can't even remember this. Oh, wait. If anybody figures out how to do that, let me know and I'll show everyone. You might not be able to do the last one. I can't remember what I did there. But any of these that you get right count as a point. What I do not, you are welcome to ask each other questions to get hints. What I do not want to see is I do not want to see that Troy and Abby have the exact same equations on every single one of these, because there's a lot of different ways you can approach them, and if I see Troy and Abby did the same thing on all of them, that is going to make me suspicious that one of them actually did it and one of them just copied everything down. So, obviously, the first one doesn't count anyway because we did it together. We probably all had a lot of the similar things there. Everything else, I don't want them to match exactly, right? So you shouldn't be matching your neighbor exactly. Maybe on a challenge or two, you might have happened to get them the same. But if I see that Smith and Troy have the exact same thing on all of their challenges, neither one of them are getting extra credit points. So you can ask each other the questions, but don't just like copy. The other good news is you're required to try at least 3 of these. If you can't get them to work, they're not going to count against you. So try at least 3 is the only thing that I ask of this. I think they're like fun puzzles, but some of them are really kind of difficult.